This is the synthesizer that I've been working on. It's 2 octave, and so here's the low end of it. And then this switch right here will switch it to the high end. Now I'd like to give a brief overview of the circuit. Over here is all of the voltage regulation for the synthesizer. So this will be the -5 and the 5-volt rails. These logic gates implement a priority network which will make sure that the highest key is the only key that's registered. This synthesizer only has one voice, meaning that we only want one key registered at a time because there's only one oscillator. There are synthesizers with multiple voices, meaning they can handle up to 2 keys or 3 keys being played at once, but this one can only handle one. On the back of the synthesizer, here we have the oscillator. This is a sawtooth wave oscillator, and its frequency is controlled by a current sink. The current sink is controlled by the voltages of the keys. So that's why we call it a voltage-controlled oscillator, because each of these voltages correspond to a certain amount of current being sunk from the oscillator, which in turn changes the frequency of the oscillator. In order to reach the 2-octave requirement, I had to add an octave switch. I only have enough keys here for 1 octave. This switch will switch in a new capacitor bank to double or half the frequency. So here's one capacitor bank, here's the other capacitor bank. Moving past the capacitor bank, we now get to the rectifier. To turn my sawtooth wave into a triangle wave, I rectify it. After the rectifier, I throw the wave through a flash ADC. And this gives my triangle wave a stepped look, which will add to the 8-bit sound that I really desired. Last but not least is the output. The output is switched on by this photo relay. When there's no key pressed, this photo relay will stay open. When there's a key pressed, it'll close the circuit. This way, the base frequency of the oscillator doesn't reach the output when I don't want it to. This is a look at the output of the synthesizer. You can see a few things. So this is the triangle wave from the rectification. And you can see the stepped characteristic, which is supposed to give it that 8-bit sound. Additionally, you can see that the triangle wave is clipped at the top. I upped the gain on the op amp to add this clipping because after experimenting with it for a little bit, I actually like the sound of this clipped waveform more than the regular pure triangle one. Now I wanted to talk about some of the reworks I've had to do. The first one I'll talk about is this switch. The synth was originally designed for a different switch, but that switch ended up not being a toggle switch and just a push button. So I just replaced it with this toggle switch. The next rework that I'd like to talk about is in the oscillator circuit. The comparator used in that sawtooth oscillator wasn't wired in correctly. It wasn't translated correctly from the LT-Spice simulation to the Altium schematics. To fix this, I implemented a through-hole comparator and I just broke out a bunch of 30 gauge wire and connected them correctly to replace that poorly added comparator. The last rework I had to do was with the rectifier circuit, turning the sawtooth wave into the triangle wave. One of the diodes wasn't wired correctly, so what I ended up doing is removing one of the SMD resistors and replacing it with a through-hole resistor where I could connect the diode correctly to its pin. One of the problems with this synthesizer is the constant hum in the background when nothing's being played, when no keys are being pressed. And that's a problem because this gate right here is only activated when any of these keys are pressed. The reason I've probed this side, the output side, and I've seen a lot of high frequency noise. My biggest suspicion and the likely reason for this is because of the capacitance across this. So there's a lot of high frequency noise that makes it through to the output channel. The solution would be to look into different gates and choose something that won't have that sort of AC coupling.